45 video lectures comprising of 5 videos for each module, and it is followed by guided learning as published articles, etc. Then 20 MCQs. I hope all you are done well in attempting the MCQs. Myself, Dr. Mahadev Gundakalle, I am a coordinator for this electives, and also I am working as an associate professor in Agriculture department in Kahir, BM Kankanwade Mahavidyalaya Belagavi, and other members are Mr. Akshay Patil. He was an assistant professor in Department of Phytochemistry in KLE College of Pharmacy, Belgavi, Karnataka, and Dr. Mrs. Neha Patil. She was an assistant professor working in KLE College of Pharmacy, and one more member, Dr. Ajit Lingayat. He is a pharmacognostic in KLE IRL College, Belgavi. This is our team. Let us start. The first module, it was the lectures on introduction to phytochemistry. What is the introduction? Its definition of the phytochemistry. Then basics of the phytochemistry, what it contains. The first module was the introduction as well as basics of the phytochemistry. And next, the sources of the drugs like animal origin, plant origin, and mineral origin. And in most of 99% of the, because phytochemistry means the chemicals which are derived from the plant, so that mainly it is related to the plant based medicines. And animal, like a good example is honey, and other minerals like what we are using in the tutor practice, like mercurial preparations, arsenic preparations, and lead preparations, etc. Then application of the phytochemistry, that is very important. Where we can apply the phytochemistry exactly in the mostly in the 90%, as we are using the phytochemistry in the preparation of medicines, and we are identifying the new drug, developing the new formulations. Then quality control analysis, that is also very important, because these all are crude form. These are we are collecting from the nature, so that the assessment of the quality is also very important in the part of phytochemistry. And analysis of phytochemistry, whether the screening of the phytochemicals, what plant contains, whether metabolites like primary metabolites, secondary metabolites like carbohydrates, proteins, amino acids, saponins, glycosides, tannins, alkaloids, volatiles, reagents, etc. Okay, this was we are studied in the first module. Then the second module, mainly we are intended to metabolites, that to primary metabolites. And metabolism is the end product of the metabolites are the end product of the metabolism. In the primary metabolites, mainly we are concentrated on the carbohydrates, proteins, amino acids. Then we are thoroughly discussed about the carbohydrates during the first module. What is the carbohydrates? We'll study in the later. Then this was also followed by the guided learning and MCQs. And in third module, that is secondary metabolites. And almost during the phytochemistry, the secondary metabolites plays very important role in the development of the drug. Okay, very important is the secondary metabolites. Okay? In that, we are studying about the alkaloids, glycosides, flavonoids, tannins, volatiles, even or reagin. Okay, in the third module, these are the secondary metabolites. I studied thoroughly about the secondary metabolites. Then the fourth module was somewhat a tedious process. What you have learned, that is different methods of extraction. Okay? What is extraction? Extraction, we are exhausting the crude drugs in the solvents. Okay? And you know the nature of the solvent as well as the nature of the drug. Depending on, we have to extract the drug. Already what you are going to study in the Ayurveda science, like preparations of Vata, Kashaya, then Hima, Font, etc. Is it not? Like that, how to extract in the modern pharmaceutics, like different methods of extraction. What are the different methods of extraction? Then Role of the solvents for the extraction process. What are the solvents? How we can use solvents like maybe a polar solvents, non-polar solvents, mid-polar solvents, polar solvents like water. How we can extract the aqueous extract, and mid-polar solvents like alcohol, methanol, ethanol, like even day to day, where as per the, if you go to the pharmacopoeia, they are told, Ayurvedic pharmacopoeia of India, they are told hydroalcoholic extracts, so that we can extract more of the phytoconstituent by using the alcohol and water, that is hydroalcoholic extract. Okay, then non-polar like ether, chloroform, etc. Then next lecture on preliminary phytochemical screening. Okay. This means just we can screen the phytochemicals, like qualitatively we can screen the phytochemicals, like we can prepare the extract and we can screen for the phytochemicals like sugars, carbohydrates, proteins, amino acids. Okay, then secondary metabolites like alkaloids, glycosides, tannin, even glycosides, cardiac glycosides, enterocrine glycosides, etc. Okay, steroids, plant acids, silages, okay, even lipids, oils. Okay, how we can screen the phytochemicals by taking the extract, that also we are studied in the fourth module. Then fractionations of the phytochemicals, how we can separate the fractionations, how we can separate, how we can purify, how we can separate the phytochemicals. That, and next is the bioactivity guided isolations of the phytochemicals, how the phytochemical works. Okay, that is also we are studied in the fourth module. This was the module 4. Then next we came to the fifth module. That was some of the advanced technology nowadays, what they are using in the uh, identification of drugs, identification of the phytochemicals, even the quantification of the phytochemicals, even the quality control methods. Okay, and the applications of the latest techniques like spectroscopy, like UV spectroscopy, infrared spectroscopy. Okay. Then chromatography techniques like thin layer chromatography, high performance liquid chromatography, HPTLC, high pressure liquid chromatography, then gas chromatography, different types of spectroscopes we are studied in the equipment. Also, one more is important is we are studied the quality control and standardization methods for the herbs. Okay, these all are the 5 modules we have studied in during the electives. Okay, then next let us start. Just once again we go through the review on what we are studied during our electives. Okay, in the first module we are came into the what are the introduction and the basics of the phytochemistry. Okay, what is phytochemistry? Phytochemistry is the study of phytochemistry when which are derived from the plant portion. Okay, phytochemistry is the study of the phytochemicals which are the chemicals derived from the plant. Okay, and very important is the proper understanding of the phytochemicals is necessary for the drug discovery. Okay, what is why we are studying means we are developing some more new drugs. We are discovering the drugs. We are forming novel formulations. That time the phytochemicals plays very important role. Okay. Maybe because of the stability or because of the getting the good therapeutic efficacy, these all plays very important role. So that the proper understanding of the phytochemicals is necessary for the drug discovery and the development of novel therapeutic agents against the major diseases. This is a very important aspect is in Ayurveda or in the medical science, we are studying the phytochemistry means we have to develop some newer drug, some novel therapeutic agents against the some of the disease, or we can replace the presenting drugs so that they can more advantage than the existing drugs. These are very important aspects when we are dealing about the phytochemicals or the phytoconstituents. Okay, what is phytochemistry? Phytochemistry is the study of phytochemicals, which are the chemicals derived from the plants. Is it not? And the way and the proper understanding of phytochemicals is necessary for the drug discovery and the development of novel therapeutic agents or therapeutic formulations against the major diseases. Okay, in broad aspect, how the phytochemicals will help us, or what are the benefits of the phytochemicals. Okay, mainly herbs, mainly mean these are benefits. They can functioning on the immune system. They can maintain the immune system. Okay, and they can protect the cells because of their antioxidant and immunomodulator activity. Okay, or they can protect the cells and tissues. Okay, and DNA from the damage. Is it not? The cell damage and the DNA damage can lead to the cancer growth. Is it not, at the development of the carcinoma? So that this phytochemicals, they can help us to protect the cells. Okay? Then reduce the inflammation. Almost all phytochemicals, they have the activity on the anti-inflammatory activity, so they can reduce the inflammation, and they can slow the growth of the newer cells, okay? Like in carcinoma. Okay, then they can regulate the hormones. Okay, nowadays, hormonal imbalance. These are also very considerable points, so that it can regulate the hormones. Then it can nourish the sensory organs. Okay, not only the one more very important benefit of the phytochemicals, they can nourish the sensory organs, and they can protect from the slow poisons. The slow poison means like cumulative poison, like what we are all your Ayurveda students, you know that Viruddhahara concept, Dushivisha concept, Garavisha concept. One another way we are taking the toxic substances into our body through the many of the, like, ahara, what we are consuming, the food is adulterated, and mainly it contains pesticides, because they all are growing with the pesticides, fertilizers. Okay, they can carry the food grains, they can carry the pesticides, and will consume. That is, will cumulatively we are introducing in our body, and later it can show the effect. So that if we are using the phytochemicals or herbs, it can reduce the effect of the slow poisons. Even many of the we are depending on the many of the drugs, like hypertension patients and diabetic patients. Even they are even thyroid. Many of the hyperthyroidism, hypothyroidism, they are depending on the drugs daily. They have to consume the uh, synthetic, that is drug, so that they can have some adverse effect. So that by using this phytochemical, they can reduce the adverse effect and toxic effect. Okay, good. Even food viruddhar, is also, it leads to the uh, disease. So that by doing viruddhar, because of lifestyle, we are all are depending upon the bhojana viruddhar, so that it also can reduce the toxicity uh, by the ahara. Then it can maintain the healthy weight. These are some broad benefits of the phytochemicals. Okay. Then next one, why knowledge of phytochemistry is essential. Okay. All you are completed, how where you can apply the uh, phytochemistry. Okay, where you can apply the phytochemistry. This is very important, so that you can apply this. Search for the discovery of new drugs or repurposing the existing ones. Very important. You can, by taking the knowledge of the phytochemicals and the functions of the phytochemicals and the structure, and all your study the structure of the phytochemicals, you can try for a search of the new drug discovery, or you can repurpose for the existing ones. Existing ones may be a maybe a costlier one, or it may have some adverse effect. So that for replace, if you found that this is a good one, you can search, or you can invent the newer drug by studying the phytochemistry. Then characterization and standardization of the traditional herbal drugs. There is also very important. There is one of the lacuna what we are facing in the herbs and herbal products. We're unable to find the original source, original stuff. It may geographically it may vary. It's not, and even many of the tribes, they are using the traditional type of traditional medicine, and they are collecting the forest, and they are unable to identify. Okay, so that this phytochemistry can help us for characterization and standardization of the herbal drugs. Okay, these are very steps, very number of steps we can standardize the herbs and herbal products. Then next is assessment of the toxic levels in the plants. That's also very important because many of our drugs, they are maybe contains pesticide residue, and they may unfit for in consume. They may contain the heavy metals like lead, cadmium, arsenic, and mercury. Those are heavy metals our plants may contain, and even aflatoxins. Okay. Then microbial contaminations, like many viable aerobic microbes may be there, and even certain pathogens also may be present. So that by studying the phytochemistry, we can assess the toxic level of the plants. Okay. Then understanding the plant physiology, biosynthetic pathway, this will help us. We can during the development of the new drug, understanding the plant physiology, even biosynthetic pathway. Then classification of the drugs, how the drugs are classified. Okay, the drugs are, the drugs are, we are studied in the model. Drugs are classified into morphological classification, taxonomical classification, chemical classification, then biological classification, pharmacological. These are different methods of classification. And chemical classification is a mean for the phytochemistry. It is not in morphological classification, pharmacology, how the external features. Then taxonomical classification, exact identification of the plants by kingdom, etc. Okay. Then chemical classification, what we are studying in the phytochemistry, like what it contains, what is the chemistry of the plants, like primary metabolites, secondary metabolites. Then biological classification means how the biologically how it is active. Okay. Then like in vitro study, by conducting the in vitro and in vivo study. Then pharmacological classification means efficacy, whether in anti-inflammatory drugs, antipyretic drugs. Okay. Like that, this can be help us for the classification of the drugs. Then one more very important is uh, by studying the phytochemistry, we can develop the environmental friendly biofungicides, insecticides, pesticides, and herbicides. It is very important. Okay? As we are discussing, our food, our medicine is contaminating by the what were artificial pesticides, because all the plants are dependent nowadays. All the plants, all the food grains, all the medicinal plants, all the food grains, what were growing by the farmers, uh, they are growing by without pesticides, without fertilizers. They can't grow now. So that we can, by knowing the exact phytochemistry, we can develop our own eco-friendly fungicides, herbicides, then pesticides that will help us to protect from the contamination. Okay, that is also very important. We can study in the phytochemistry. One more is food preservation. By identifying certain phytochemicals, we can preserve food, because our food is preservative. In previous days, class 1 preservatives are used, like madhu, ghrata, taila, sharkara, then Guda. Nowadays, these all are replaced by chemicals. What we reach, if you go to if you see any packet of pickles, any packet of sauce, what they written? It contains, it is preservated by, it is having the preservative class of preservatives. They are nothing but the sodium benzoate, benzoic acid, citric acid. These all are synthetic. They may have very harm effect, because daily we are consuming. So that by studying this phytochemistry, we can develop our own preservatives. Okay. Then next comes then the second module was on primary metabolites. In the primary metabolites, uh, we were studied about the carbohydrates. Is it not? Carbohydrate is one of the important factor. It is produced in the primary metabolism. Okay. What is the carbohydrates? Carbohydrates are the organic compounds, also called the hydrated carbs. Is it not? Carbohydrates are the organic compounds, also called as the hydrated carbons, and they contain the carbon, hydrogen, and oxygen atom. Is it not? Then they are classified into monosaccharides, disaccharides, oligosaccharides, and polysaccharides. This was thoroughly we are studying what are the structure, functions of the primary metabolites during the third module. During the second module. Okay, what are the carbohydrates? Carbohydrates are the organic compounds also called the hydrated carbons containing the carbon, hydrogen, and oxygen. Okay, these are classified monosaccharides, disaccharides, oligosaccharides, and polysaccharides. And very important, we have studied the many of the drugs like examples also. Okay, and many of the drugs, our drugs like Shatavari, Gokshura, they contain a lot of carbohydrates. They are energy source. Okay, even like Bala, these are containing the carbohydrates, and you know how to screen it. It can be Benedict solution. We are studied in the screening of the phytochemical module. Okay, and carbohydrate is one of the best energy source. Okay, it is a primary metabolite, but if you come only it gives the energy. But if you compare to the phytochemistry means medicinal invention, it may not be help, but the secondary metabolite will really help. We'll see later. Okay. Okay. Then carbohydrates classified as monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Like sucrose, maltose, fructose. Then starch is a good example for a polysaccharide. These all are we are studied during the time of carbohydrate. Then second is the proteins. What are the proteins? Protein is a complex high molecular weight organic compound. Is it not? Protein, mainly the seeds that contains the proteins. Mostly all of the plant, the seeds are containing the proteins. Okay, what are seeds we are using therapeutic like? Okay, that contains the proteins. What is the protein? Protein is a complex high molecular weight organic compounds that consist of the amino acids, and these are joined by the peptide bonds. Okay, proteins. Proteins also give the energy, and it helps for the tissue growth. Proteins are mainly help for the cell growth and tissue growth. Okay, and proteins these are mainly energy source. Okay, protein is a complex high molecular weight organic compounds that consist of the amino acids joined by the peptide bonds. And they are classified into simple, conjugated, and derived. Okay, how proteins are classified? They are classified as a simple, conjugated, and derived proteins. Okay. And in carbohydrates, hexose sugar, pentose sugar, and even we are studied about the how to screen the pentose sugar, hexose sugar, etc. In proteins also we are doing some of the tests to identify to screen the protein. But next in third module we are studied the secondary metabolites, and secondary metabolites are the very important phytoconstituents. These are very important role in the therapeutic activity. Okay, secondary metabolite. In secondary metabolites, first we are studied the alkaloids. Okay, let us start what are the alkaloids. Okay, what do you mean by alkaloids? Alkaloids are alkali-like substances. Okay, before going to the in detail, what is the alkaloids? Alkaloids are the alkali-like substances, and alkaloids are defined as a basic heterocyclic nitrogenous compounds of a plant. Got my point? Alkaloids are defined as basic heterogenic nitrogenous compounds of a plant origin and have marked physiological activity. Okay, alkaloids are because the name came, these are the alkali-like substances. Alkaloids are defined as a basic heterocyclic nitrogenous compounds of a plant origin and have marked physiological activity. And these are classified into true alkaloids, protoalkaloids, pseudoalkaloids, and fast alkaloids. Got my point? These are classified into true alkaloids, protoalkaloids, pseudoalkaloids, and false alkaloids. And almost all the activity are depending upon the alkaloids. Good example for the alkaloids like piperine, one of the very important alkaloid what we are studying day to day. Piperine, it contains piperine. Many of the studies have been conducted on piperine. Okay, is one of the best. It also acts as a catalyst. Okay, so that piperine is one of the ingredient almost all the formulation. Okay, piperine, even it present in the piperine and maricha. Okay, then one more is one good example is reserpine. It is an alkaloid present in the sarpagandha, so that it has an anti-hypertensive sedative activity. Like there's so many, like aconitin is alkaloid present in the Vatsanava. In curcumin, one of the very important aspect, curcumin is present. This alkaloid is present in Haridra. It has very good. Many of the activities shown. It is antipyretic activity. It has shown. It has shown good antiseptic activity. It has good anti-inflammatory activity. Even curcumin is good best anti. It showing good results against the cancerous cells. Okay, curcumin. These are the alkaloids. These are the some of the alkaloids like curcumin. Many of the I am quoting some example like curcumin, reserpine, piperine, ruvidin. These are the many of the alkaloids. They are extracted from the plants. Okay, and these are directly using in the therapeutic activity. Okay, but our concept is we are Ayurveda people. We know that we studying drug as a whole. Sarvadravyam Panchabotikam. Panchabotikatvam is not. We study the Rasa, Guna, Virya, Vipaka. Okay, along with that Rasa, Guna, Virya, Vipaka, we can some more we can study about the in deep into the like phytochemistry that will really help us during the discovery of newer drugs, also by using in we are finding the patient needs. Okay, then next comes the tannins. Okay, tannins, alkaloids. Then next is the tannins. What are the tannins? Tannins are the complex organic non-nitrogenous polyphenolic substance of the higher molecular. Okay, alkaloids are the nitrogenous heterocyclic nitrogenous compounds. Tannins are the non-nitrogenous polyphenolic substances with the high molecular weight. Okay, and these tannins having the they have the astringent activity. They are taste like astringent. Okay, then the alkaloids they are bitter in taste. Like this also help us for our rasa can identify rasa because the tikta rasa and the like katu rasa maybe alkaloid may present more. Like that we can hypothesis can be done, and many studies are also published. The kashaya rasa astringent taste they can contain a rich amount of tannins as okay. Then madhurasa they contains rich amount of carbohydrates and flavonoids. Okay, like this also we can somehow we can correlate with this phytochemistry and our rasaguna, virya, vipaka concepts. Okay, tannins are the complex organic non-nitrogenous polyphenolic substance of the higher molecular weight, and these are classified into true tannins and pseudotannins. Okay, these are classified into true tannins and the pseudotannins. Again, true tannins are classified into hydrolyzable, then condensed and the okay. These are again classified into hydrolyzable tannins and condensable tannins. Okay. Mainly the good example for tannins are like acacia, katechu, like khadira, the arjuna, then panchavalkala. These are ashoka. Many of the astringent kashaya rasatmaka drug contains a rich amount of tannins, and tannins showed very good effect in as a anti-diarrheal like utaja. Anti-diarrheals. If you go to the text, they are quoted that these having the anti-inflammatory, wound healing, as well as a, and they Kashayaras also as a Shitaguna because it do the Raktaskandi. If you go to the modern science also, the tannins, they can prevent the hemorrhage. They can stop the hemorrhage. Like that, we can correlate our concept with the along with the modern phytochemistry. Okay, tannins are the complex organic non-nitrogenous polyphenolic substances of the higher molecular weight, and they are classified as true tannins and pseudotannins. And good examples are for tannin rich, even tea powder is contains rich amount of tannins, flavonoids, okay, tannic acid. And one more important is tannins are we are commonly using as antidote also. Okay, it is Vishagna, best Vishagna. Okay, even it is anti-inflammatory and it is anti-diarrheal. And other thing, the tannins commonly used in the leather industry, dyeing industry, fabric industry, because they having the coloring agent tannins. So that this about the tannins, and we are thoroughly studied in the third part. Then flavonoids. What are the flavonoids? Flavonoids are the variable phenolic structure found in the fruits, vegetables, grain, bark, root, etc. Is not flavonoids are the phenolic structures, variable phenolic structures found in the common in the fruits, vegetables, even bark, root, grains, etc. Okay. Flavonoids. Okay, and you know flavonoids play very important role in the immune building. Okay, like these are very good immunomodulators and they have good antioxidant effect. Then glycosides. What are the glycosides? Glycosides, these are the organic compounds. Glycosides are the organic compounds obtained from the plant as well as the animal sources. Glycosides are obtained from the plant as well as animal sources, and because of the enzymatic activity or acid hydrolysis, they use one or more sugar moiety. Okay, sugar moieties along with the non-sugar moiety. They give the one or more sugar moieties along with the one or non-sugar moiety. Okay, these are the glycosides and different types of cardiac glycosides, glycosides, etc. who are studied in the module. Then terpenoids. What are the terpenoids? They smell. They are giving the smelling agents. Terpenoids are the volatile substances which gives a plant's flower by their fragrance. Okay, they can give the fragrance to the plants, flowers, etc. Terpenoids. Okay. Then these things we have studied in the third module. Then let us come to the fourth module. In the fourth module was entirely on the extraction method. Okay, we have studied the different types of extraction methods. Okay, in that solvent extraction, steam distillation, then superficial fluid extraction, and distillation. These are the methods we have studied during the general extraction method. First one is the solvent extraction. Yes? And solvent extraction, we studied the maceration. What is maceration? Very important. What we have to do? We have to take the crude drug in the coarse powder form and we have to add the solvent. Known quantity of the solvent can be added and we have to occasionally shake it for 18 hours and we have to keep it for allowed to stand it for 6 hours, total 24 hours. Then we have to filter it and prepare the extract. Okay, this is ideal method for the cold maceration method. Okay, and for water for aqueous extract also is very ideal method, cold maceration method. The thing is that we have to take the coarse powder of the known quantity and known quantity of the solvent can be added and we have to shake it continuously for the 18 hours. Nowadays shakers are available, so that you have to keep on a flask shaker for 18 hours and then allow it to stand. Sorry, you have to say shake it on a 6 hours and allow it to stand for 18 hours. After 24 hours, 6 hours shaking and 18 hours allowed to stand. Total 24 hours. Next day you can filter it. After filtering, then you have to operate on a water bath and you have to collect the extract. This is a very simple and ideal method for the old extraction method. And one more is percolation, then infusion, decoction. You know, infusion like hot infusion and cold infusion, what we are doing in the Mantakalpana and even Himakalpana. Okay, sorry, Fantakalpana and Himakalpana. Infusion methods. Cold infusion is a Himakalpana and hot infusion is a Fantakalpana. Already we have studied. Then decoction, like preparation of water. 1 part of drug, 4 part of water, and maybe water part may be vary depending upon the nature of the drug. 4 part, 8 part, 16 part, jala can be taken, and we have to boil on a mandagni until we will get the one. It should be reduced to 1/4. Like that, we have to prepare in the decoction. Same method can be adopted during the solvent extraction. And one more is continuous hot extraction, with oxalate extraction method. These are one of the ideal method for the preparation of the extract. Here, we'll get the oxalate extraction efforts. It containing 3 parts. One is a round bottom flask, middle part is a thimble, that is exactly oxalate. Then one upper part is a condenser. Okay, in the round bottom flask, what we are keeping the solvents, and in middle part with thimble, it contains a crude drug. In the crude drug, it contains 2 pipes. One is a siphon tube, one is the air vent. And when the solvent is heated, it gets evaporate and it enters into the air vent, and it condenses by the water, cold water. Then drop by drop, it will come into the thimble. Then it will extract the whole drug whole. When it reaches the siphon top, automatically it is empty because of the gravitational force into the round bottom flask, so that it is continuously, the cycles are going on, so that it is called the continuous hot extraction. These have some advantages and disadvantages also. Advantage, it may be it doesn't require more manual. Once you set, it can automatically prepare the extract. Then disadvantage means thermodegradable chemicals maybe we may lost. Okay. Then one more, then steam distillation, then superficial fluid extraction, then miscellaneous like sublimation, expression, then pre-operation, then microwave treatment. All these are the different types of the extraction methods we are studied in the 4th module. Okay, this we are studied in the 4th module. Okay, then next, the last module was on the last module was on the application of latest techniques. Okay, what are latest techniques? Like simple techniques are thin layer chromatography, okay, like partition chromatography. Here we are identifying the drug by the retention factor. One more advanced technique is the instrumental method is the HPTLC, high performance thin layer chromatography, HPTLC. Then HPLC, high pressure liquid chromatography, gas chromatography, GCMS, okay, gas chromatography, mass spectrometry. These all are some advanced techniques. What are the how to use, what are the principles? Okay, then one more, spectroscopic methods, infrared spectroscopy, ultraviolet spectroscopy. These methods we are studied in the 5th module. These very important techniques we can apply in the phytochemistry. Okay, these are some tedious method, and if you got any if in like opportunity to attend such workshops, you can attend, so that you come to know that how we can use the latest techniques in the in the herbs, identifying the herbs and standardizing the herbs. Okay, these we are studied. Then one more is important is a one more point we are discussed in the standardization methods, standardization and quality control aspects. What is standardization? Standardization means determination of its quality, purity by various parameters. Okay, we are adopting the various parameters to ensure that the drug or the medicine is having the quality, it has purity. Okay, And quality means already predetermined certain parameters are there, it should pass on the particular parameter. Standardization means various steps to determining the quality, purity, and purity of the drugs. Okay, mainly in plants. What are the parameters are mainly organoleptic, botanical. Then next, one more is physical, chemical, and biological. Because it is differ from the formulation to single drug. Here, phytochemistry means we are using the single drug or extract, so that these are the parameter standardization of the herbs. Parameters may be a organoleptic, botanical, physical, chemical, and biological. Okay. First one is the organoleptic. Organoleptic means we are applying our organs like eye, ear. Okay. Then sense of taste. Okay. Means color, which by we are applying the sensory organs. So that's called the organoleptic. Color, odor, how it smells. Okay, what is the taste of the drug? Okay, these all are comes under the organoleptic characters. Okay, then next one is the botanical. Botanical may be the macroscopic and microscopic. What is macroscopic? Macroscopic means naked eye. Only we can see whether it is a leaves or whether it is a bark or whether it is a seed, whether it is a fruit or fruit tree, anything we can by naked eye we can identify the drug. Okay. Then microscopy means by using the microscope. One we cannot see the by the naked eyes, like shells, structure of the cells, parenchyma, parenchyma, okay, then palisade ratio. Everything can be studied by the microscopy. Okay, it can be done by the simple compound microscope or by using the trinacular, binocular microscope. We can study the microscopy. Then what is the physical? Physical in that we can study the moisture, extractive values, and ash. Moisture means water content. Okay, and every drug is definitely it contains a water. Thing is that it should come if it water content is more, then that can allows for the growth of microbes, so that the drug will become a deteriorate and it can spoil, so that water content can be assessed in the form of loss and drying. Is it not? Means thing is that we have to keep the drug in a hot air oven and we have to evaporate the water and we can calculate the percentage of water. By that we can assess the water content or moisture content. Then extractive values like water soluble extractive, alcohol soluble extractive. This how we have studied in the fourth module, like general extraction methods. Okay, cold maceration methods also. And because it should have the extractive value, means it should be extracted in the aqueous or alcohol or some other intermediate. If the phytochemicals are rich, then only you can extract it. Extractive value very less, the plant may be deteriorated or you can lose, it has lost the active ingredients. So that process that we have to perform the extractive values. The organic, mainly extractive values for organic compounds, and the ash is for the inorganic compounds. Ash is nothing but the carbon free compound. It requires some instruments like muffle furnace, crucibles. Okay, the known quantity of the drug to be taken, and it should be kept in the muffle furnace for 450 to 500 degrees Celsius, or until it becomes the complete carbon-free material, fruitless. And weight can be taken, and we can measure the total ash. And if you go to the pharmacopoeia, they are given the every drug, the how much ash to be there. Okay, that gives the purity or the strength of the drug. Okay, that is mainly the inorganic elements. Then one more is a chemical methods. Okay, these like it requires what we have studied chemical methods in phytochemistry or chemistry of the plants, like preliminary phytochemical screening, HPTLC, GC, GLC, HPLC, etc. Okay, these are also very important to assess the phytochemicals, the quantification of the phytochemicals. Then next one is the biological standard biological methods. In the biological methods, we are testing the microbial contaminants, total viable microbes, certain pathogens like E. coli, etc. Then other part is the toxicological assessments like heavy metals, pesticide residue, aflatoxins. Okay? And mainly the heavy metals are they are given certain part per million. They should not cross that level. Okay, mercury, lead, arsenic, and cadmium. These are the heavy metals can found in the plants, original drugs, so that it should be under the limit. Then aflatoxins, then pesticide residue. These are some of the important parameters to assess the quality and purity of the drugs. Okay. Now we are came to the end of this session. I hope if you have any difficulties for further communications, my number, my email ID also I have shared. If you have any doubt, you can put the queries, and we hope this will continue. Continuous interaction will continue, and I also thank all the organizers. They have given me an opportunity uh, for this to conduct, to coordinate this electives, that is introduction to phytochemistry. Thank you. Namaskar.